So let's think about this series here that we're asked to evaluate. Does it converge or diverge? This is a geometric series, and it might not look obvious at first, but we're going to do a little bit of manipulation to get it to that point. Now remember that a geometric series is denoted as either n equals 0, where we have a to the r to the n, right? So in this form. Or you can say, okay, I want to make my n start at 1, and this will be n minus 1. Here we have the second case where n is equal to 1. We're starting at a value of 1. So we have to rewrite this. So we have n minus 1 for each of the powers, right? We'll see that some things happen here, but the thing that happens here is notice that we have a negative n exponent. Remember, if we have x to the negative 1, we can rewrite this as 1 over x, right? Those simple exponent rules that you've probably learned before. X to the negative 1, no, it's 1 over x. So we're going to do that here with both of these to make n positive, right? It's going to help us with our manipulation of this problem. So this is actually negative 6 to the n minus 3 over 8 to the n minus 2. Right, we just took the signs of the exponents and flipped them. Hopefully that's pretty easy to see for you. This is probably the hardest step here, realizing you can do this. You probably look at it and be like, oh, I can do that. Make it in terms of that are a little bit easier to see. And then we need to get this in terms of n minus 1. Now, let me write something out that might be a little confusing, but hopefully it will make sense. We need to get 8 to the n minus 2 times 8 to the n minus 1. Well, remember our exponent rules. If we have some value a to the n power, and we have it multiplied by a to the n again, oh my goodness gracious, n. Well, we just add the powers, and this becomes 2n. Well, in this case, we could say, we could multiply this by 8 to the negative 1. We add, and we'll get this, okay? We multiply the terms, but we're adding the exponents. That's how we get this term back here. So hopefully that wasn't too bad to see. That's another kind of hard step, but we can rewrite it as 8 to the negative 1, 8 to the n minus 1. And we'll do the same thing with the denominator here. We will say that, okay, negative 6 to the negative 2. Alrighty, and this is going to be equal to negative 6 to the n minus 1. Now you're looking at this, you're like, uh-oh, that looks kind of ugly. Well, remember our negative exponent rules, we are again going to flip these here. So this is going to become negative 6 squared over 8. All right, and this becomes 8 to the n minus 1 over negative 6 to the n minus 1. We're allowed to pull this out as a constant. Let me actually figure out what that is. 6 squared is going to be 36 divided by 8. This is going to be 9 over 2. And we're going to have 8 over negative 6. 8 divided by negative 6. This is going to be negative 4 over 3 n minus 1. Okay, so we found our series and we put it in terms of how we've seen the geometric series written. So if we want to rewrite the series, we could say, okay, this is our actual series in the notation that the geometric series wants. Alrighty. Now we just ask ourselves a few questions. Does it converge or diverge? Well, we know that for this value here, if it is greater than 1, well, as we increase the n value, it's going to increase the value towards infinity. But if it's less than 1, if this value is less than 1, or less or greater than negative 1 in this case, if it's inside the bounds of the 1s, well, then we know that this is going to simply decrease, 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 because 1/2, for example, times 1/2 is going to give you 1/4. So if we put an n, 1/2 to the n, and we plug in infinity, well, we know that that's going to approach infinity, or sorry, not infinity. It's going to approach 0 which is it's just going to constantly keep going down. And that would be convergent, and then we'd have to find it. But notice here, we are out of the bounds of the 1, -1 to 1. We're out of those bounds. So this number is going to increase indefinitely. And therefore, we can say for sure, using that logic, that this is a divergent series. This geometric series in particular is going to diverge until infinity. All right, I hope you guys enjoyed this episode. If you did, please drop a like, comment, and subscribe if you have any questions. Or not subscribe, comment if you have any questions. Have a wonderful day.